Welcome to the second video of rotational mechanics, where we will basically do some previous year questions, mainly from IIT JAM and JEST, which are coming from the topic moment of inertia. So almost, I think we will solve all the questions which has come till 2005 to 2022. So in the previous lecture, I have already told about the moment of inertia and some moment of inertia of different rigid bodies, then almost the steps to do the moment of inertia of rigid bodies. Then we have derived some of them. The first of is that moment of inertia of straight rod wire and moment of inertia of ring, disc, triangular lamina, and the square lamina, all of this. So already we have done, and the last we have done this important question. This question is pretty much important, and today is actually the application part of all that I have done in the previous video. And so let's start then. Well, the first question is from IIT JAM 2022, where we are asked to find the moment of inertia of a square laminar set with side A and mass m. Means this side is A of mass m, and we're given the mass per unit area, which is sigma x equals to sigma naught into 1 minus x by A. So to find the moment of inertia about the y-axis, I think this axis, right? So let's draw the picture again. This is our square lamina, and this is the length, that is A. So first we will take the element, and in this case we will take a strip element to integrate over this square lamina, and that is of thickness, small thickness dx at distance x. So basically we have taken a small thickness dx and at a distance x, and we will integrate over 0 to a, right? So first of all, dm equals to sigma x into dA. dA is of the element, and the element dA equals to A into dx, right? So that is sigma naught 1 minus x by A into A dx. So we have find the elementary mass. Let's simplify this. Sigma naught A dx minus sigma naught, in this case A will cuts out, x dx. This is our dm, right? And the next step is to find the moment of inertia of the elementary strip, that is di equals to dm into x square. Now this part we found, we have simply write this dm into x square, because this is the axis and this is our strip, right? This is the strip. This is of a small thickness dx, and each of the particle, let's say this particle, this particle, this particle, all are at distance of x. So as we have done in case of a single particle, that is m1 at the distance r1, I equals to m1 r1 square. So in case of this strip also, all the particles in the strip are at same distance from the axis. So you can simply write that the moment of inertia of the strip is equals to mass of the strip and the distance from the axis. Okay, so now I equals to, that is the total moment of inertia, equals to integration of di. So we do the integration from 0 to a equals to integration of sigma naught a x square dx minus sigma naught x cube dx from limit 0 to a. Let's go to the next page. So I equals to 0 to a sigma naught x squared dx, sigma naught x squared dx minus sigma naught x cube dx. Okay, so a sigma naught x cube by 3, this is 0 to a minus sigma naught x to the 4 by 4, 0 to a equals to sigma a to the 4 by 3 minus sigma naught a to the 4 by 4, that is equals to LCM 12, and that is 4 minus 3, so sigma naught a to the 4. So we got our moment of inertia, that is I, right? And if we check the options here, we can see that the moment of inertia are in terms of mass. So what we need to do now, that we have to convert this sigma into the mass term. So let's take this term dm equals to sigma naught a dx minus sigma naught x dx. If we integrate the elementary mass from 0 to a, so we get the total mass. So let's integrate this. M equals to integration of dm from 0 to a equals to 0 to a sigma naught a dx, sigma naught a dx minus sigma naught x dx. That is sigma naught a square minus sigma naught a square by 2 equals to sigma naught a square by 2. So that is equals to the total mass, right? So sigma naught equals to 2m by a square. Now put this equation, put this sigma naught in this equation. So from 1 and 2 we get I equals to 2m by a square into sigma naught, sorry, a to the 4 by 12. Now a square e to the 4 cuts, and in numerator we get a square, and 2 cuts with 12 equals to 6. So m a square by 6 equals to the I. So that is our final answer. So option C is correct. Let's go to the next question from JAM 2021. So this question is saying that the moment of inertia of a solid sphere about an axis which is at this distance of r by 2 from the center. This is quite straightforward, which is asking like let's say this is our solid sphere and we are asked to find the moment of inertia in this axis I1, and we also know that the moment of inertia from the center of mass of a solid sphere is 2 by 5 mod square. So from parallel access theorem we can easily say I1 equals to IC plus M into R by 2 whole square equals to 2 by 5 A mod square plus A mod square by 4 equals to 20 for 8 plus 5 AMR square equals to 13 AMR square by 12. Right? So option C is correct. Now from this question is saying that the mass per unit length of a rod, length 2 meter, varies as 3x kg per meter. The moment of inertia in kg into meter square of a rod about a perpendicular axis passing through the tip of the rod at x equals to 0. So it says that, let's say we have a rod here of length 2 meter, and we need to find the moment of inertia about this axis, right? So in this case also, let's take element dx, and we're given that lambda, that is the mass per unit length, equals to 3x kg per meter. So the elementary mass dm equals to lambda dx, which is equals to 3x dx, right? So simply find di equals to dmx square, I equals to integral di 0 to 2, as the length of the rod is 2 meter. So it is simply 0 to 2 3x dx, that is the mass, into x square equals to 0 to 2 3x cube dx equals to 3 x to the 4 by 4 from 0 to 2, and that is equals to 3 into 2 to the power 4 by 4 equals to 12, right? So option B is the correct answer. So this question is from JAM 2018, where we're asked the moment of inertia of a disk of radius r having uniform surface density have a concentric hole of radius r2, that is less than r1. If its mass is m, then the principal moment of inertia r. So the principal moment of inertia means basically ix, iy, iz. We have to find all these things. Okay. Let's say this is our disk of outer radius r1 and inner radius r2. So we have taken an element of dx thickness. So first of all, we will find the elementary area of our elementary ring. So that is 2 pi r, 2 pi x, that is actually from x distance from the axis, 2 pi x into dx. And if you find the mass per unit area, that is sigma, sigma equals to m by pi r1 square minus r2 square. So let's find the moment of inertia, that is di of the elementary ring, that is di equals to dm into x square. As we know that moment of inertia of a ring is mr square, so that equals to dm. So dm equals to sigma dA, that is equals to m 2 pi x dx by pi r1 square minus r2 square. So that is equals to 2 pi m x dx into x square by pi r1 square minus r2 square. And we have to integrate this to find I. Let's do it in the next page. So I equals to integral di from r2 to r1 equals to 2 pi m by pi r1 square minus r2 square x cube dx which will integrate from r2 to r1, right? So pi and pi cuts, 2m by r1 square minus r2 square, and that is x to the 4 by 4, which will take the limits from r2 to r1, which equals to 2m r1 to the power 4 minus r2 to the power 4 by 4, and here we have r1 square minus r2 square. So we can say that 2m into r1 square plus r2 square into r1 square minus r2 square. We just simplify it here, r1 square minus r2 square into 4. So r1 square minus r2 square cuts out, 2 to the 4. So the final answer we get m r1 square plus r2 square by 2. So that is our IZ. IZ means this part. This we have find out with the perpendicular axis with the plane of the disk. So we have to find Ix, Iy and Iz also. So to find Ix and Iy, let's say this is our ring. We are finding the Iz, and let's say this is our Ix, this is our Iy, Ix, and this is our Iy. From perpendicular axis theorem, we can say that Iz equals to Ix plus Iy. And as you can see here, that both are same, both Ix and Iy are same. So we can say 2 into Ix, as Ix equals to Iy. So Ix equals to Iy equals to Iz by 2, that is equals to m r1 square plus r2 square by 4. So hence we get all the principal moment of inertia, right? So this is our next question, and it is from JAM 2017, and here we are asked that consider a uniform thin circular disk of radius r and mass m, and a concentric square of side r by 2 is cut out from the disk. What is the moment of inertia of the resultant disk about an axis passing through the center of the disk and perpendicular to it? So we are asked here to find the moment of inertia of the disk with the perpendicular axis, where we have cut out a square lamina from the disk. Now I want to find the resultant moment of inertia after we have cut out the square lamina, right? So we can divide this into two parts, that is the initial disk of radius r and the square lamina which we have cut out of side length r by 2, right? Let's say moment of inertia of this part is I1 and this part is I2. So basically the resultant moment of inertia is nothing but I1 minus I2, because we have cut out the square lamina from the disk. So we have to minus this term from the initial part, right? So the initial moment of inertia, that is I equals to, in case of disk, m r square by 2, and in case of this square lamina, let's say the mass of the square lamina is m1. So here, let's draw it. This is the square lamina, and we are asked to find the moment of inertia about its center, right? So find this, we know that the moment of inertia of a square lamina about its diagonal is I equals to ml square by 12, which I have told in my previous video. So to find, let's say this is Iz and this is Ix. So we can say that Iz equals to Ix plus Iy. Let's say another diagonal, this is Iy. This is also ml square by 12. So Ix equals to Iy. So we can say Iz equals to 2 into Ix. So Iz equals to 2 into ml square by 12 equals to ml square by 6. So our desired moment of inertia, that is I2, equals to m into the length square, that is r by 2 whole square by 6, that is equals to m r square, that is m1, because the mass of this lamina is m1 r square by 24. Now, so we have this I1, that is m r square by 2, and we have I2, that is m1 r square by 24. But now we cannot subtract, because we have to find the relation between m and m1, right? So to find the relation between m and m1, here, in this case, this is m1, and in this case, this is m, right? So the area of this lamina is r2 square, r by 2 the whole square, equals to r square by 4, right? And in this case, the area is equals to pi r square. So from here we can say that mass per area, that is sigma, equals to m by pi r square. So the mass of the lamina, that is m1, equals to sigma into r square by 4. That is equals to m by pi r square into r square by 4. So r square and r square cuts, that is equals to m by 4 pi equals to m1. So we got the relation between m and m1. Now just write I equals to I1 minus I2, where I1 equals to mr square by 2 and I2 equals to mr square by 24. So I1 equals to mr r square by 2 minus m1, that is m by 4 pi into r square by 24. So let's take m r square by 2 as common. 1 minus 1 by 48 pi. So that is our final answer, and that is option B is correct. So let's move to the next question from JAM 2015. So here it is saying that 7 uniform discs, each of mass m and radius r, are inscribed inside a regular hexagon as shown. So we have a regular hexagon, and where we have 7 uniform discs. So we have to find the moment of inertia about the axis passing through the central disk. So we have to find the moment of inertia about the central disk, about the axis passing through the central disk and perpendicular to the plane of the disk. Well, so simply the moment of inertia is equals to, let's say, let's number the disk. This is 1, 2, 3, 4, 5, 6, 7. 7 disks. So the moment of inertia equals to the moment of inertia for the one, that is half mr square, because as the axis is passing through its center, plus 6 into m half mr square plus m into 2r whole square. Now this is actually because, let's say this is the central disk, and disk is beside of the disk, and the distance between the two center is 2r. So from parallel axis theorem we can write this. So finally we come to half mr square plus 3mr square plus 4 into 6, that is 24 mr square. So finally we get mr square as a common. 1 plus 6 plus 48. So that is equals to 48 plus 6, that is 53, plus 1. 48 plus 6, that is 54, plus 1 equals to 55. So 55 by 2 mr square, and that is the final answer. So the next question says, to find the moment of inertia of a disk about one of its diameter is Im, and the mass per unit area of the disk is proportional to the distance from its center. If the radius of the disk is r and its mass is m, then the value of Im is. So basically we have a disk here, and we are asked to find the moment of inertia about its diameter, that is Im, where it is given that sigma, that is equals to the mass per unit area, is varies as x, that is the distance from its center. So we can say sigma equals to kx, where k equals to constant, right? And we have to integrate over this axis, but it is easy to find the moment of inertia across the axis which is passing through its center. So we can take a elementary ring and integrate over 0 to r, so that we can find the moment of inertia across the center and perpendicular to the plane. So the thickness of
the ring is dx and it is x distance apart. So the elementary area dA is 2 pi x dx, and the elementary mass of the ring is sigma into dA equals to 2k pi x square dx. And if you integrate the dm, we will get the total mass, that is integration of dm from 0 to r, we will get 2k pi 0 to r x square dx, that is equals to 2k pi r to the power 3 by 3. And now we will find the moment of inertia of the elementary ring, that is di equals to dm x square, as the moment of inertia of a ring is m r square. So now we will find the total moment of inertia, that is integration of di from 0 to r equals to 2k pi x square dx into x square and integration over 0 to r, that is equals to 2k pi x to the power 4 dx and integration over 0 to r, that is equals to 2k pi r to the power 5 by 5. So that is the value of I, but you can check from the options that the moment of inertia is in terms of m. But more precisely, if you say that this I is actually I of z, this I of z, that is perpendicular of the plane, but we are asked to find Im. So from perpendicular axis theorem, we will find Im from Iz. Just for simplicity, we have taken the axis Iz to find the moment of inertia after integrating. So we know from this is the value of the m. So from this equation, you can get the value of k. So k equals to 3m by 2 pi r to the power 3. So put this value of k here and you will find the Iz. So the Iz is Iz equals to 2 pi r to the power 5 by 5 into the value of k, that is 3m by 2 pi r cube, 3m by 2 pi r cube. So 2 pi cuts, r cube cuts with r square. So we will get 3m r square by 5. And according to the question, we are asked to find the moment of inertia across its diameter, and we have find in the question the moment of inertia across the center, right? So you can say, let's say this is I of m, this is I of z. So from perpendicular axis theorem, you can easily say that Iz equals to 2 into Im. So Im equals to Iz by 2, that is equals to 3 r square by 10. So option C is the correct answer. Now this question is from JAM 2009 and a pretty important question. So this question is saying that moment of inertia of a solid cylinder of mass m, height L and radius r about an axis passing through its center of mass and perpendicular to the symmetry axis. So we're given a cylinder like this and we have to find the moment of inertia from its center and passing through the symmetry axis, means like this. You are rotating the axis like this. So we have to find the moment of inertia. So in this case, I have drawn earlier that in this case, we will take an elementary disk. We will take an elementary disk and we will integrate the disk over this region. Over this region. Okay. So the mass of the elementary disk is equals to m by L into dx, right? So we will find, so like this, this is our axis, this is the disk which we have taken. So to find the moment of inertia across this axis, we have to use parallel axis theorem. First we will find, let's say this is Im, this is Iy. So Im equals to Iy plus m into dm into, let's say this is x square, right? Now the Iy is like, if we have a disk and we are rotating it by its diameter, we know that Iy equals to dm r square by 4, because uh, the moment of inertia of a disk about its diameter is mr square by 4. So simply we will write here dm r square by 4 plus dm x square. Now put the value of dm here, that is equals to m by L into r square by 4 into dx plus m by L into x square. So this is the value of the moment of inertia of the elementary disk, and we have to integrate over the whole cylinder. We can also integrate the half cylinder and multiply with 2 also. So let's do it. So from this part, we have this is our cylinder, and this is the ring, right? And the elementary moment of inertia which we have get is equals to m by L r square by 4 dx, m by L r square by 4 dx plus m by L x square. So to find the total moment of inertia, that is I equals to di, let's say in multiply with 2 and integrate over 0 to the x. This is L distance, so this distance is L by 2, so we will integrate over 0 to L by 2 plus L by 2 and multiply 2, so that is L by 2 equals to 2 into integration of 0 to L by 2 m by L r square by 4 dx plus m by L x square dx. So from here we will get 2 into m by L r square by 4 into L by 2 plus m by L into L cube by 3 into 8, right? So L and L cuts, here we will get L square. From here we will get 2mr square by 8 plus 2m L square by 24, that is equals to mr square by 4 plus ml square by 12. So this is the final moment of inertia about this axis, about this axis. So this is the end of the video, and almost I have covered all the questions which has come from 2005 to 2022 in this topic. I will recommend to practice all of this once again in copy, and in JEST 2016 also there is a question from this topic, but as it is from the similar concept, so I have not done it here. You can check it. So well, goodbye then.